Hi everyone, this is Dr. Nak, and today we're going to be learning about inverse functions. Let's first go with the definition. It says that suppose that f is a one-to-one function, the correspondence from the range of f back to the domain of f is called the inverse function of f, written f to the negative 1. But we read this as f inverse. Now please note this. I know it's so tempting to do. F inverse, this does not equal to 1 over f, by the way. So f inverse is just a notation. Also, another very important thing is this. In order for the inverse functions to exist, your function f must be one-to-one function. So in case you forgot what the one-to-one means, it means that for each y, there is exactly one x value. Now, picture-wise, it passes the horizontal line test. So, for instance, right, suppose you have a parabola that's looking like this. Now, this whole entire graph is not one-to-one. Not one-to-one, because it fails the horizontal line test. Because if I draw a horizontal line here, it intersects the graph at 2 points, not exactly at 1 point. Now, please note this. However, if you chop this graph in half, and then if I just look at the one side of the graph, then your inverse function exists because this half of the graph is one-to-one. Now, in case you forgot what the definition of a function is, it means that for each x, there is exactly one y value. So again, please note that in order for the f inverse to exist, your function must be a one-to-one function. So let's just draw a little picture to understand what's going on. Alright, so consider this picture. So suppose that this is the domain of f and this is the range of f. So where does the f go? Well, f takes the element from the domain of f and then it's going to map onto the range of f. Now, where is f inverse? Well, f inverse is going to go backwards. It's going to start from the range of f and then goes back to the domain of f. So here will be the picture. Now, notice that your range of f becomes the domain of f inverse. And the domain of f becomes the range of f inverse. So let me write that. So with that said, we can conclude that the domain of f must equal to the range of f inverse, and that the range of f is same thing as the domain of f inverse. Okay, so let's try to understand what's going on here again. So who lives inside the domain of f? Just x, right? So if f is going to take x to the range of f, and the notation for that will be f of x. All right, now what we're going to do is this. We're going to take our f of x, and then we're going to apply f inverse to go back to the domain of f, which is same thing as the range of f inverse. Now, if I do that, do you see what's going to happen? Well, the first notation would be this. Let me see. So if I take f of x, apply f inverse, and go back to the domain of f, and then that notation is going to be, oh my gosh, I'm running out of room. So this is same thing as f inverse of f of x. Hopefully you can see that. Okay, but what do you know? F inverse of f of x, well, is it not just exactly equal to x? So that is the relationship that we can get out of it. So if f inverse is the inverse of our function f, then this needs to happen. F inverse of f of x better equal to x. Also, if I start from the function f inverse, then, so what I'm saying is, suppose this is our sum value. You can call it x or y, whatever you want to. But anyway, so here's the inputting. Let's just call it x just for heck of it. Now, if I apply f inverse to this point, right, then what's going to happen is that our f inverse is going to take our x into the domain of f. So the notation for that will be f inverse of x. All right. Now what we're going to do is we're going to take our function f and then bring this f inverse of x back into the domain of f inverse, or the range of f. And the notation for that will be, can you tell me what the notation is going to be? It's going to be, let me see, I am running out of room. So this is going to be f of f inverse of x. But the thing is, that better equal to our starting point, which is x. So therefore, if f and f inverses are truly inverses of each other, then this also has to hold. F of f inverse of x better equal to x. And for this case, let me just write it out, where our x is in the domain of f inverse. And this x right here is, let me just write, x is in the domain of f. So guess what? In order for us to check whether given f and if inverses are truly inverses of each other, then what we need to do is we have to check these two criteria. But we'll get to that in a minute. Now, before we start doing something more complicated, let's start out with the good old ordered pairs. All right, so here, let's take it as example 1. For the set of ordered pairs, -3, -27, -2, -8, -1, -1, 0, 0, 1, 1, 2, 8, 3, 27. So we have 4 questions here. Part A, is this function one-to-one? Part B, does the inverse function exist? Part C, find the domain and a range of the function. Part D, find the domain and a range of the inverse function. So, are we ready to do this? So let's first determine whether this function is one-to-one or not. Alright, so here is part A. What I did was I just drew the picture from the domain to the range of our function f. So is it one-to-one? Remember, the definition of one-to-one, for each x, there better be exactly one y value. So in this case, I believe that yes, this is a one-to-one function. So I'm going to box that for the answer. Now, let's go with part B. Does the inverse function exist? Well, what was the criteria in order for the inverse function to exist? Well, your function must be a one-to-one function. So in this case, we just determined that f is a one-to-one function. So yes, inverse function does exist. So I'm going to write that out. Yes. I'm just going to call it f inverse exists because f is a one-to-one function. I'm not going to box that. All right, so now let's go with part C. Find the domain and a range of the function. So our function, we're talking about the function f here. All right, so let's first go with the domain of f and the range of f. Now, domain of f is all the set of all x values. So you're going to have -3, -2, -1, 0, 1, 2, and a 3. All right, now what about the range? Okay, so the range is going to be -27, -8, -1, 0, 1, 8, and then 27. So I hope this part was okay. All right, now let's go with part D. Find the domain and a range of the inverse function. Now, remember the argument that we discussed before. Remember that the range of f is same thing as the domain of f inverse, because remember, f inverse goes this way. So in fact, let me see. The range of f is going to become the domain of f inverse, and the domain of f becomes the range of f inverse. All right, so I think, sorry, I didn't want to write the whole list out, so I just made that relationship. So our answer D will be this. Hopefully this example was not too bad. So now let's look at the next statement. Testing inverse relationship. It says that given two functions f of x and g of x, f and g are inverses of each other if f of g of x equals to x and g of f of x equals to x. Now remember that argument that we made earlier. If f and f inverses are truly inverses of each other, then what happened? We had to go f of f inverse of x better equal to x, and f inverse of f of x better equal to x. We talked about that earlier. Now, instead of calling it f inverse, we're just calling that functions to be g, because I'm not 100% sure whether g is truly going to be an inverse of f or not. So for an example, so let me just I'm just going to let f of x to be x cubed. And then let's let g of x to be 1/3 x or something like that. Now the question is our g, is it going to be an f inverse? Now how do I check is this: if f and g are inverses of each other, then each other, I can't even write nowadays, then f of g of x must equal to x and g of f of x must equal to x. So if one fails, then it's no longer inverse. So let me just check this. So let's check f of g of x. All right, so remember how to compute it. So we got a f of 1/3 x, which is same thing as 1/3 x to the third. So that's same thing as 1/3 to the third. That does not equal to 9. That's 27. And then x to the third. But this does not equal to x, right? So in this case, we know for sure that f and g are not inverses of each other. So let me just write it. All right, so don't worry, we're going to do some examples in a minute. Let's take a look at example 2. Given f of x and g of x, determine whether f and g are the inverses of each other. Let's go with part A. Let f of x be x cubed and g of x equals cube root of x. All right, so in order for it to determine whether f and g are the inverses of each other, we have to compose f of g of x and g of f of x, and we're going to cross our fingers and we're hoping that they're both going to equal to x. So let's check. All right, so let's first go with f of g of x. So that's same thing as f of cube root of x, which is same thing as cube root of x whole thing to the third power. Look at it. Boom, x. All right, so halfway done. Okay, sorry, that was like the biggest check mark, huh? It does not have to be that big. So let me just go. I got too excited, sorry. So it checks. All right, now let's go with g of f of x. So we get g of f of x is x to the third. So which is same thing as what g of x is cube root of x. So you got cube root of x to the third. So this is going to give us an x back. Yes, so therefore, yes, f and g are the inverses. All right, so I'm just going to leave it as that. All right, so let's take a look at another example. Part B, let f of x equals 2x plus 3 and g of x equals 1/2 quantity x minus 3. All right, so we're going to do the same thing. So let's first check f of g of x. So we got f of 1/2 times x minus 3. All right, so this is same thing as 2 times 1/2 times the x minus 3 and then plus 3. All right, so now what's going to happen is that I'm just going to distribute the 2 into 1/2 because everything's being multiplied. So that means that I get to cancel that out. So what's left over is just x minus 3 And then we have plus 3, which is going to give us x. All right, so it's looking good. Halfway done. Now let's go with g of f of x. Okay, so now what do we get? G of, okay, our f of x is 2x plus 3. So that's same thing as 1/2 times 2x plus 3 and then minus 3. I don't know why I put the parentheses there, but anyway, so this is same thing as, let's just simplify what's in the parentheses first. You got 2x plus 3 minus 3, so that's just going to give us a 2x. Multiply that with 1/2, we're going to get x back. So again, we say that f and g are the inverses of each other. So far so good. Hopefully you're getting comfortable with the composition of functions. Would you like to do another one? Let's do it. All right, let's look at part C. As you can see, I'm trying to increase the level of difficulties as we go along, but we can do this one. All right, so let's do the same thing. So are they inverses of each other? So let's first check f of g of x. So that's f of g of x is negative 2x all over x minus 3. So then this becomes, so f is 3x over x plus 2. So you're going to have 3 times, do not freak out, negative 2x over x minus 3. And now whole thing divided by negative 2x over x minus 3 and then plus 2. Do not panic. We got this, okay? We can do this. All right, now remember the trick. Multiply everything through by the LCD of all the 3 terms that you see. So in this case, our LCD is x minus 3. We've done this before in the previous section. So I'm going to multiply this whole thing by x minus 3. And I'm going to do the same thing here. All right, so now what I'm going to do is I'm just going to simplify the numerator first. So what do we get? So if I multiply everything through, then do you see that only thing that we can cancel is our x minus 3. That's the whole point of why we're multiplying everything through by the LCD, so we can get rid of the fractions. So who's left over? We have 3 times the negative 2x. Look at how cute it looks now, right? The power of LCD. All right, now whole thing over. Now what we're going to do is we're going to distribute the x minus 3 to each term and cancel what we can. So if I distribute the x minus 3 to the first term, then do you see that I can I can cancel out both x minus 3 and then who's left over? Just negative 2x. And then don't forget to distribute that x minus 3 to 2. And here what we're going to get is plus 2 times x minus 3. Look at that. Not as bad as you thought, right? So then let's just keep simplifying. So you got negative 6x all over negative 2x. Now I'm going to distribute the 2 to get plus 2x and then minus, what is that? Minus 6. All right, so then what do we get? Negative 6x all over. Now this is going to cancel out to be 0, and then you're going to just have minus 6. Why is my fraction bar so big? I don't know. So let me just erase it a little bit. So look at it. Now I could cancel out the negative 6's and then get x back. Yes. All right. So halfway done. Now let's check the other way. G of f of x. So we got g of f of x. So this is g of 3x over x plus 2. Okay, so then this is same thing as negative 2 times 3x over x plus 2. Whole thing over, what is that? 3x over x plus 2 and then minus 3. I know it looks fugly, but we can do it. Okay, let's do the same trick. LCD. What's the LCD? Yes, x plus 2. So we're going to multiply everything through by the x plus 2. And then this whole quantity by x plus 2. All right, so now for the numerator, remember everything's being multiplied. That's the reason why I can cancel the x plus 2's out. So what's left over then? You got negative 2 times 3x is left over. Now, whole thing over. Now what I'm going to do is same thing as what we did earlier. I'm going to distribute x plus 2 to each term. Then for the first term, if I distribute the x plus 2, I can cancel out the x plus 2. And who remains is just the 3x. And then minus, now I'm going to distribute the x plus 2 to 3 to get minus 3 times the x plus 2. So far so good. Alright, so then this is same thing as negative 6x all over 3x minus the 3x and then minus 6. Alright, so then looking good. 3x is going to cancel out. Then we have negative 6x over another negative 6. So look at it. Boom. We got an x back. Alright, so yes. Therefore, f and g are the inverses. How you all doing up to here? Getting hang of it? Do you need more examples or should we move on? I say let's move on and we can come back to it if we need to. Alright, our next topic is this. The previous examples, you're given two functions and then you're asked to determine whether those two functions are the inverses of each other. But now the game is a little bit different. Given a function, we're asked to find its inverse. Okay, so how do we do that is this. Procedure for finding the inverse of a one-to-one function. Again, inverse does not exist unless your function's one-to-one. So here we go. Step 1. Interchange the roles of x and y. Step 2. If possible, solve the equation for y in terms of x. That's called explicit. To obtain the explicit form of f inverse. Meaning, solve for y equals, now on the right hand side, everything must be in terms of x. Meaning, you should no longer have a y on the left hand side and a right hand side. Alright, so now step 3. We have to double check to make sure that we computed them correctly by checking f of f inverse of x, is that going to equal to x? And f inverse of f of x, is that going to equal to x? So those are the 3 steps that we're going to have to do. Let's do some examples. Example 3, find the inverse of the following one-to-one function. Let's go with part A, f of x equals 4x plus 2. Alright, so we're going to follow this step. Okay, so step number 1, what we need to do is interchange the role of x and a y. Remember, y equals f of x, correct? So in this case, we're going to have to swap your y with x. So we're going to have x equals 4y plus 2. That's your first step, interchanging the roles of x and a y. And then step 2, if possible, solve for equation for y. We want to solve the equation explicitly. All right, so can we do that? I think in this case we can. So we subtract 2. So we have x minus 2 equals to 4y. Now dividing out by 4, then it looks like, let me just go on this side here. So it looks like we're going to have y equals x minus 2 over 4. Or remember, this is same thing as x over 4 minus 2 over 4, which is same thing as x over 4 minus a 1/2. Depending on what the function is given to you, when you check f of f inverse and then f inverse of f, your computation can be easier if you use x minus 2 over 4 or x over 4 minus 1/2, but it doesn't really matter which form that you want to use. But anyways, I don't know which way you saw it, so let me just keep my first one as our answer. Now, after you were able to solve for y explicitly, meaning, notice that on the right hand side, there is no more y's, right? So we're good to go. So call that of final y as f inverse of x. Okay, so I'm going to write it as, therefore, our claim is that our f inverse of x is going to equal to x minus 2 all over 4. All right, so let me just box that. Now we're going to verify. Okay, so this is the very important step. So we check. So let's first go with f of f inverse of x. Now, is that going to give us the x back? Okay, we're crossing our fingers that it's going to equal to x, but let's do it. So this is same thing as f of x minus 2 over 4. So this is same thing as, okay, don't forget your f of x. Our f of x is 4x plus 2. So here you're going to have a 4 times x minus 2 over 4 and then plus 2. So then what? I can cancel out the 4s. So then what do we get? We have a x minus 2 and then plus 2, which is going to give us x back. Looking good. All right, now let's go with the other way. Is f inverse of f of x, is that gonna give us x back? Please give us the x back. All right, so ready? F inverse of f of x, which is 4x plus 2. So then we're gonna look at our f inverse and then plugged it in 4x plus 2 in place of x. So here you're gonna have 4x plus 2 and then minus 2 all over 4. Okay, so now what? I can cancel out the 2's. So then we're gonna have 4x over 4, which is gonna give us our x back. All right, so therefore, yes, our final answer is that f inverse of x equals x minus 2 over 4. Let's take a look at another one. Let f of x equals negative 3x plus 1 all over x. All right, so let's do it. So step 1, interchange the roles of x and a y. So we're going to have x equals negative 3y plus 1 all over y. All right, now our job is to solve for y. So what do? Well, I will multiply by y on both sides. Let me just go like this, y and then y. So then here you're going to have a xy equals, now if I multiply by y on the right, I can cancel out the y's, right? So then you're going to have a negative. Now be careful here. Notice that our negative sign is outside of the fraction, right? So this, also, I should have mentioned this first. So this notation means this is same thing as negative 3x plus 1 all over x, by the way. All right. So here you need to put the parentheses around 3y plus 1. Okay, so please be careful right there. All right, let's keep going. So I'm going to distribute the negative sign, and we're going to have xy equals negative 3y minus 1. Now remember, you're trying to solve for y, so bring all the y's onto in this case I'm going to bring it on the left hand side by adding 3y to both sides. Then here what we're going to get is xy plus 3y equals negative 1. All right, now can I solve for y equals something? I think I can, because look, can I not factor out the y? So you got a y times x plus 3 in a parentheses equals to negative 1. So now what we can do is divide everything by x plus 3. So it looks like our, let me just bring it over here, y equals negative 1 over x plus 3. So I'm just going to claim our f inverse of x to be negative 1 all over x plus 3. So I'm going to box that for the answer for now. Now we check to make sure that we computed it correctly. All right, so that's our step 3. Oops, I forgot to write step 2, huh? There you go, step 3. We're going to check f of f inverse of x. Is that going to equal to x? All right, so let's compute. So we got a f of f inverse is negative 1 over x plus 3. So where's my f of x? There you go. So you got negative 3 times negative 1 over x plus 3 plus 1 all over negative 1 over x plus 3. Do not panic. We can do this. All right, what was the trick? Yes, LCD. So in this case, our LCD is x plus 3. So let's multiply everything through by x plus 3. All right, ready? I know it looks really nasty, but we can do this. So I'm going to leave the negative sign here. Now, I'm going to distribute this whole entire x plus 3 to this term, and then the second term here. So what's going to happen if I multiply by x plus 3 on the first term, notice that our x plus 3 is going to cancel out. So who's left over? We have negative on the front of it, and then you're going to have 3 times the negative 1, and then plus 1 times, now I still have to distribute x plus 3 to 1, so you're going to have 1 times x plus 3, whole thing over. Now on the bottom, on the denominator, you can just simply cancel out the x plus 3, and then who's left over is just negative 1. All right, so far so good. So then remember, this means that you have a negative, and then this negative attached to the numerator if you want, or you can toss it on the denominator, but don't forget that there is a parentheses there. So you're going to have a negative 3, and then plus x, and then plus 3, whole thing divided by negative 1. So now what? Can I cancel out the 3's? Yes. So then here, what do we get? We got negative x is left over negative 1. So negative over negative makes a positive. So we're going to get our x back. All right, looking good. Now we need to check f inverse of f of x. Is that going to equal to x? All right, so ready? We got a f inverse of f of x. What was my f of x? We got minus 3x plus 1 all over x. Is that right? Yep. All right, so now let's focus on f inverse. So we have negative 1 all over negative 3x plus 1 over x, and then plus 3. Okay, I know it looks nasty, but remember the trick, LCD. So what's the LCD? It looks like just x. So let me just multiply x. And then on the numerator, we're going to have a negative x. On the bottom, let me just keep the negative sign out here. Now, if I distribute this x to each term, then for the first term, notice that I'm going to able to cancel out the x's. So then on the bottom, I have negative parentheses 3x plus 1. And then plus, now don't forget to distribute the x to 3, so you're going to have another 3x. All right, I'm trying to do this step by step by step, so hopefully you can follow me. So then this is same thing as negative x over. Now I'm going to distribute the negative sign to get negative 3x minus 1, and then plus 3x. Kill the 3x's. Now what do we get? We have negative x over negative 1. So we're going to have a positive x back. Yes. So therefore, our f inverse is in fact negative 1 over x plus 3. All right, let's look at part C. F of x equals x squared plus 9, where x is greater or equal to 0. So in this case, this is called the restricted domain. Do you see why it's restricted? Because look, we just learned how to graph x squared plus 9 by transformation of graphs, right? So let's take a look. All right, so let's draw let's do the transformation of the graphs, right? Because we just learned it. So first, let's draw x squared. So that's a parabola, right? And when x is 2, y should be 4. Where is 4? 1, 2, 3, 4. Does that look right? So it kind of looks like this. By this time, you should know my artistic skills, which is 0. All right, so here is, pretend that's y equals to x squared. Now, plus 9 means what? You're going to have to shift this graph upward by 9 units. So let's see, 1, 2, 3, 4, 5, 6, 7, 8, 9. So, oh no, I'm going to run out of room here. And then, oh, sorry, I'm just going off the graphing paper here. But so anyway, so here is the graph of y equals x squared plus 9. Now, let's look at it. Without the restricted domain, x is greater or equal to 0, is this a one-to-one function? This is not, because it fails the horizontal line test, right? So this is not one-to-one altogether. However, if you restrict the domain to x is greater or equal to 0, it's not just this piece here. I don't know if you can see that. Is that better? So we're only looking at the right hand side of x squared plus 9. So if I just take that one piece, do you see that the function becomes 1-to-1 because it passes the horizontal line test? Oops. All right, but anyways, to find the inverse is exactly the same procedure. All right, so let's start. So step 1, interchange the roles of x and y. So I'm going to have x equals y squared plus 9. Now don't forget to interchange the role of x and y for the restricted domain. So you're going to have y is greater or equal to 0. All right, so now let's see. We're going to have step 2. Can we solve for y? I think so, because I could subtract the 9 to get y squared equals to x minus 9, where y is greater or equal to 0. Now be careful on the next step. If you solve for y, if I take the square root on the y squared, you're going to have a plus or minus, right? So you're going to have a y equals plus or minus the square root of x minus 9, right? We have a problem here. I could not solve for y explicitly because look at it. We have y equals positive square root of x minus 9 and a negative square root of x minus 9. So altogether, your inverse not going to exist. However, look at this beautiful domain restriction. This is telling you that your your y better be greater or equal to 0, means y has to be positive. You're only going to take the positive part of y, so we get to keep just one function. So here what we're going to get is our y equals square root of x minus 9. Now, what is the domain of square root of x minus 9? Well, whoever sits inside of the square root has to be greater or equal to 0. So x minus 9 has to be greater or equal to 0. That means that x better be greater or equal to 9. So altogether, before I box that, let's call that f inverse. So therefore, our f inverse of x is square root of x minus 9, where x is greater or equal to 9. Altogether, that's going to be our f inverse. All right, so far so good. Okay, so now let's check. F of f inverse of x. Is that going to give us an x back? All right, so we got a f of square root of x minus 9. So which is same thing as the square root of x minus 9 whole thing squared plus 9. So which is x minus 9 and then plus 9. So this is going to give us our x back. Good. All right, now let's check f inverse of f of x. Is that going to give us an x back? All right, ready? F inverse of f of x, which is x squared plus 9. So that's square root of x squared plus 9 minus 9. Okay, so then I can cancel out the 9's together to get square root of x squared. So in this case, we're only taking the positive side, so this is going to become x. So we're good to go. Okay, so therefore, f inverse of x is square root of x minus 9 such that x must be greater or equal to 9. All right, let's just look at this graphically. Okay, so what I did was I graphed out our function f of x, which is x squared plus 9 with the restricted domain, and f inverse of x, which is the square root of x minus 9, where x is greater or equal to 9. Do you notice something about that picture? If you don't see it right away, that's fine. Let me just draw this line real quick. All right, this is the line where the equation is just y equals to x. Now, pretend that this is like a paper, right? If you fold this paper along this line, y equals to x, do you see that the two graphs is going to match each other? Do you see that okay? So in fact, this is actually going to be a relationship between f and then f inverse graphically. So given f of x, your f inverse must be, we say that this is symmetric with respect to the line y equals to x. And with that said, here it is. How to find the inverse function from the graph of the function. It says that the graph of a one-to-one function f and the graph of f inverse are symmetric with respect to the line y equals to x. That's exactly what happened to our previous example. Let's do some examples. So example 4, the graph of a one-to-one function is given. Draw the graph of f inverse of x. Let's take a look at this. Our f of x is 4x plus 2, and the black line is y equals to x. Now, this is the same exact problem that we did in example 3a, and we were able to come up with our inverse function. So our inverse function, f inverse of x, was x minus 2 all over 4. So let's do this. So if you're not, good at drawing pictures like me, you can always make yourself a chart for your function f, which is x, y equals 4x plus 2. And then just start punching in some numbers here. So let's take our x is like maybe -2, -1, 0, 1, 2. And let's compute the corresponding y value. So you're going to have 4 times -2 plus 2, which is -6. All right, and then we're going to have 4 times -1 plus 2. So that gives us -4 plus 2 is -2. And when x is 0, it's going to be 2. And then 4 times 1 plus 2, it's going to give us 6. And then 4 times 2 plus 2 is 10. So right now we have -2 comma -6, and then -1 comma -2, 0, 2, 1, 6, and then 2, 10. Now remember the inverse. Inverses, you just swap the the coordinates, right? So here you're going to have, instead of -2, -6, you're going to have -6, -2. And then here you're going to have, instead of -1, -2, you're going to have -2, -1. You got the idea. 2, 0, 6, 1, and then 10, 2. So those are the points that you might want to plot. So let's go with -6, 2. Goodness, we don't even have -6 on this our x-axis, so let's skip that one. So let's go with -2, -1, -2, -1. That will be here. All right, and then 2, 0. All right, and then, oh goodness, 6, 1 is not even there. But as you know, we better get a line, right? Because if you fold this, think of it as a paper, and if you fold this along the line y equals to x, you will get a straight line. So let's just draw that line. Oops, so let's just pretend that this line passes through this point. Just make the dot fatter. All right, so this is in fact our graph of f inverse of x. Do you see that? Well, it may not look quite perfectly symmetrical with respect to the line y equals to x, but it's supposed to be. All right, let's look at part B. Again, we did this in example 3, and in fact this was a second problem. I believe it was part B. So f of x equals -3x plus 1 all over x, and then our inverse we came up with was -1 over x plus 3. Okay, so we already computed those, so let's take a look. So I am so horrible at doing this, but you can do the same thing as what we did earlier by making a chart. So here again, I randomly chose some values for x. Now let's just compute the corresponding value for y. So you're going to have a negative. Remember, you make sure to put a bracket here. You got to have 3 times the -2 plus 1. Oh no, I'm running out of room. All over the -2. So this is going to be negative. Okay, so in the bracket, you have 3 times -2. -6 plus 1 is -5. All over -2. So it looks like you're going to have positive 5 over -2, so it's -5 over 2. So that's same thing as -2.5. I'm converting into a decimal so that way I can easily plot the point. And when x is -1, you're going to have -3 times -1 plus 1 all over -1. So this is negative. You got -3 plus 1, -2 all over -1. So what is that? 2 over -1, so it's -2. All right, now let's go with when x is 0. Notice that we're gonna end up getting a 0 in the denominator. So at x equals to 0, your y value is undefined. All right, now let's go with when x is 1, then you're gonna have negative 3 times 1 plus 1 all over 1, so which is negative 3 plus 1 is 4 over 1, so it's just negative 4. And when x is 2, you're gonna have 3 times 2 plus 1 all over 2. So what do we get? Negative 7 over 2, which is negative 3.5. All right, let's see what's gonna happen. So let me just write down the ordered pair, negative 2 comma negative 2.5. And then you got a negative 1, negative 2. 0 undefined, so I'm not going to even go there. And then 1 comma negative 4, and then 2 comma negative 3.5. So our inverse has to be negative 2.5 comma negative 2, negative 2 comma negative 1, negative 4 comma 1, and then negative 3.5 comma 2. All right, let's cross our fingers. Okay, so let's plot those points. So negative 2.5 comma negative 2. Well, let me see. So this is negative 3. So negative 2.5 is here, comma negative 2. So at this point here. And then negative 2 comma negative 1. And negative 4 comma 1. And then negative 3.5, and then comma 2. All right, so let's make a sense out of this. So again, remember, you're folding this paper along that line, y equals to x. So most likely you're gonna have a graph that's gonna look something like this. Oh my gosh. Oh, dear Lord. Does that look okay? It looks all right. And then remember, don't forget this little piece right here. So if I reflect that, maybe I'm gonna have a graph that's looking something like this. Does that look all right to you? I'm just gonna leave it as that. That looks so beautiful to me. Anyway, so I'm gonna end the lecture here for this section. So again, great job. And if you have any questions at all, you know where to find me.